Hello, this video is about slope, and it's just a really quick rundown on slope in algebra. Now, what is slope? Slope is a way of describing an incline, whether it be upwards or downwards, an incline. You may be looking at this and saying, well, this one's a little steeper than that one, but you need to be a little more exact with it, especially when you're talking about construction. You need to have numbers involved to describe it. Well, I could go with the angle here, and the angle here would tell me how far up or down, but that doesn't really tell me much about how much material I would need in this direction or how much material I would need in this direction to help build that particular ramp or side of a building or wherever it is I'm building with this slope on it. So we need a way of expressing slope, this incline here, measuring it using the length and the height, not so much the angle. And what we've done with that is we've come up with something called slope. And we'll come back to Mr. Slope a little bit later. Now, if we've got this line here, let's say this is a line, it's got an incline, and we want to describe its slope. To do that, we find a reference point. And I'm looking at this reference point here. I think that's a good one because it's got a nice, easy to read y value, a nice, easy to read x value. I find another point like that, let's say up here, that's got a nice, easy to read x value, a nice, easy to read y value. And then I work with the change in the height over the change in the length there. This will help me to figure out how far up and how far over it is to get to that next point. To get up there, I count up 1, 2, 3, 4. There's a change of 4 there. And then over here, there's a change of 1, 2, 3, 4, 5, 6. So my change in the height is a change of 4. My change in the length is a change of 6. If I do that change in height over the change in length, I get 4 over 6. Well, that can be reduced. So I reduce that, I would get 2/3. And this is how I describe the incline of this line, the slope of that line. For every 2 I go up, I can go over 3 and I can find another point on the line. No matter where I go, if I find another good point, looks like it crosses nicely here. If I go up 2 over 3, it's going to hit the line again. Well, actually it's here. Up 2 over 3. From here, up 2 over 3. If I go from here, I'm going up. Up 2 is almost here. 3 is right about there, so it's close. You're going to find out that no matter where you are on that line, if you go up 2 and over 3, you're going to end up at another spot on the line. So the slope is 2/3. Now, when you're given those 2 points, we could calculate it using the x and y values there. This x value would be 1, 2, 3. So this is 0.3, comma. The y value is 1, 2, 3, 4, 3, 4. So you have the point 3, comma 4. And this point is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 for the x, and 1, 2, 3, 4, 5, 6, 7, 8. 8 for the y. And we're going to find a way we can use those 2 points to find this slope. If you look at it, the change from here to here, the change of that y, is it went from 4 to 8. So that's the 8 minus the 4. That change in y is a 4. The change in the x value went from 3 to 9, which is 9 minus 3 is a change of 6. That same rise over run we got there. And when we reduce it, we get that 2/3. What does this boil down to? Well, the basic concept of slope is you have a rise over a run. The change in y over the change in x. This is slope in terms of words. There's also another way of writing it with a delta. The triangle shape is a Greek letter. It stands for change in. So delta y over delta x is the same as saying change in y over change in x. For some odd reason, they decide to use the letter m for slope. And if we write the equation using the 2 points like I just did with the points in the last graph there, this is point 1, this is point 2. We give them subscripts of 1, subscripts of 2. We can plug in values for y2 minus y1 over x2 minus x1. Not very clear. I don't like this formula. I hate these subscripts and stuff. Let's take a look at it. Try a couple. When you try a couple, you'll see it's not too bad. Alright, here we have 2 coordinates. And we are asked to find the slope of the line between those two. Using the formula, which says y2 minus y1 over x2 minus x1, this would be the first point, so that would be x1. This would be y1. This is the second point, x2, y2. When I plug in these values, I would do 7 minus 3, y2 minus y1, over x2 minus x1, 4 minus 2. I end up getting 4 over 2, which reduces to 2. Now, if I did the same equation, the same thing, but I switched the points. Let's say I solve this point first instead of that point. I would actually be doing this as 3 minus 7 over 2 minus 4. y2 minus y1 over x2 minus x1. Backwards. If I do that, 3 minus 7 is going to give me negative 4. 2 minus 4 is going to give me negative 2. A negative over a negative is a positive. So this still works out to be 2. So it turns out, I don't care which one of these is point 1 or point 2. I'm still going to end up with the same slope as long as I make sure this x and this y come from one coordinate, and this x and this y come from the other coordinate. So technically, I could write that equation as m equals y minus y over x minus x. That kind of looks like something. To me, it kind of looks like 2 martini glasses sitting on top of a picnic table. That's how I remember the formula. Y is on top, x is on the bottom. Let's try with another set of points here. Here we have negatives involved. That might change things. Let's see what happens. y2 minus y1 would be 1 minus a negative 2. x2 minus x1 would be negative 5 minus 3. Minus a minus becomes a plus. So 1 plus 2 is 3. Negative 5 minus 3 is negative 8. So this works out to be negative 3/8. If I switched it around, I would have had negative 2 minus 1 over 3 minus a minus 5. Minus a minus becomes a plus. Negative 2 minus 1 gives me a negative 3. 3 plus 5 gives me an 8. I still end up with negative 3/8. Either way, it's still the same slope. So the formula is pretty straightforward. What happens, we got some little odd cases here. Let's check this one out. In this case, when I do the slope, I do the y minus y, 7 minus 7 over 11 minus 3. 7 minus 7 is 0, 11 minus 3 is 8. 0 divided by 8 is 0. Can slope be 0? Yes, it can. So that's a fine answer. When you end up with a 0 on top, you do need to write it as a 0 because it should not be left as 0 over 8. It needs to be simplified. Simplified response is 0. So in this case, our slope is 0. Over here, we have 0 minus 9, y minus y, over x minus x, we get 4 minus 4. 0 minus 9 is negative 9. 4 minus 4 is 0. Wait, now there's a 0 on the bottom. Can you divide by 0? No. So when you've got this situation, the slope is actually undefined. All right, so slope can be 0, but when you have a divide by 0, your slope is undefined. What do these look like? Let's take a moment to think about that. If my slope is 0, that means if I start off at this point here, my change in y over my change in x is going to be 0. So when I change from this y to this y, this x here, these points here, my change in y is going to be 0. And I want the top to be 0. Remember that top number was 0, 0 over 8, right? So my change in y was 0, my change in x was at 8. So the x can keep changing, but my y value can't. My y value changes to 0. I get a horizontal line. Horizontal lines. Horizontal lines have a slope of 0. Now, let's say I have my negative 9 over 0 slope. Well, if I'm starting off at this point, my change in y is going to be negative 9, so I would be going down, but then I wouldn't go to the left or right any at all. So my rise keeps going up and down, but my run is nothing. I can't go left or right. So no matter where I start, I'm going to end up with a vertical line. In this case, it would be the y-axis. In this case, it would be the vertical line over here, whatever point this is. So a slope of undefined is a vertical line. Now, an easy way to remember these is to work with Mr. Slope. This is a positive slope. If we look at money over time, this being my money, this being time, as time goes by, the values in this graph are getting larger. That would be a positive thing. If I had that switched around, if I was going this way, as time goes by, my money would be going down, which would be a negative thing. If I have a vertical line, we said our slope was undefined. Horizontal line, we said the slope is 0. And that's where Mr. Slope comes from. Sloping in this direction is positive, this direction is negative, vertical is undefined, horizontal, you have a slope of 0. Thank you.